So in this video, we are going to discuss some examples of the pigeonhole principle and how we can use it. So here goes the first example. Show that among any group of 367 people, there must be at least two with the same birthday. So first, we must find the pigeonholes and the pigeons. So we can interpret the 366 days of the year as the pigeonholes, and the number of pigeons will be the 367 people. So what we can say here is that the pigeons will be interpreted as the um, objects or numbers, and the properties will be the birthdays or the pigeonholes. Okay, so how can we use the pigeonhole principle? Given that we have 366 days of the year and we have more people or we have more pigeons, 367, then at least one of these birthdays or days of the year will contain two or more birthdays. So we can then say that there must be at least two people with the same birthday. So we can visualize it like this. So assuming we have these days of the year from January 1 to December 31. So let's say that the first 366 people is mapped to every day of the year. Okay, and then this 367th person will be then celebrating its birthday similar to any of the first 366 people that we have. Or we could also visualize it like this. So assuming there will be days without anyone celebrating their birthday, and there will be days wherein there are at least two people who are celebrating the same birthday, like in January 2 as well as December 31. Okay, and we can have, let's say, another example, 3 people who are celebrating their birthday on January 2, and 2 people celebrating on December 31, and other people not celebrating their birthday in other days of the year. Or maybe we could have all these people, 367 people, celebrating their birthday in only one day of the year, but that is not realistic. Okay, so let us have another example. Show that in any group of 27 English words, there must be at least two that begin with the same letter. So we must find the pigeons and the pigeonholes. So we can interpret the letters as the pigeonholes, and the number of pigeons will be the 27 na English words. So at least one of these letters contain two or more words. So in other words, at least one of these English words will start with the same letter. All right, so there must be at least two words that begin with the same letter. So we can visualize it like this. So suppose we have these 26 letters and there is an associated na word for each na letter. Okay, so the A starts with alligator, B for bear, etc. So since we have 27 English words, so it means that, let's say we have another word here, turtle. So turtle starts with letter na T, and this will be binned or mapped to this letter T, which means that this pigeonhole T will have two na pigeons, or in other words, two that at least begin with the same letter. Okay, so how many students must be in a class to guarantee that at least two students receive the same score on the final exam if the exam is graded on a scale from 0 to 100 points? So we must find the pigeons and the pigeonholes first. So the pigeons will be the students, and the pigeonholes will be the score of each of these students. Okay, so we have how many pigeonholes? 0 to 100. So how many students must be in the class to guarantee that at least two receive the same score? So suppose that for each score, we have a pigeonhole that contains a student which got that score in the exam. So we have this student got a score of 0. this student got a score of 1, etc. And we have the one last na student here, that, or the 101st na student, which will have the same score with the first 100 students that we have. Okay, so the number of pigeonholes is, let's say, 101, 0 to 100. So by the pigeonhole na principle, the number of students must then be 102 or more. So we can say that, or so we can ensure that at least 2 students receive the same score on the final exam.